and switch over to Tim's slides and give Tim control of the slides.
Okay.
So let me do a little official introduction. So my name is Marquette, and I'm the project manager for the Northern Grapes Project. Today's webinar is Impact of Crop Load and Training Systems on Viticultural and Enological Performances of Marquette and Frontenac grown in Michigan and New York. It's a long title. Our speakers today are Tim Martinson and Paolo Sabatini. Tim, who directs the Northern Grapes Project, is a Senior Extension Associate at Cornell University, and he also directs the statewide viticulture extension program. Paolo is an assistant professor at Michigan State University, and he has research and extension responsibilities in viticulture. So thanks, guys. I'm glad to have you both speaking today. Remember that as a participant in the webinar, you will not have the ability to speak. If you're having any technical difficulties, please type a note in the chat pod over on the right side of the screen, and I'll do what I can to help. If you have questions that come up, go ahead and type those in the chat pod as you think of them. And we're going to take a break after Tim's presentation to address some questions, and then we'll have some time at the end after Paolo's presentation as well. So with that, Tim, I'm going to let you take over.
Okay, thank you, Kristen. It's really a pleasure to be here for the final webinar of the year, and I'm very happy to be able to present some data from our project, and Paolo's going to do the same thing. The last webinar I did was a couple of years ago with Mike White, and we talked about canopy management and sort of the principles of canopy management. And so it's really great to have some data that we can share with you from the first 2 years of the project. I've found through the years that doing viticultural studies, 2 years of data isn't quite enough, but we're going to present it here. I have some pretty dramatic results from New York, and I think Paolo has some very interesting results too. So this is what we'd like to share with you today. We are applying for renewal of the Northern Grapes Project this year, and hope to continue on for through 2016 with the project. But right now, funding-wise, we're running on fumes because our funding was for 2 years, and we're in the 3rd year of the project. So what I would like to talk to you about today is some training trials that we did on Marquette and Frontenac up in Clayton, New York. And Kristen has done an awful lot of work on this stuff, and so have I. And I think we have some interesting results. And here we are studying vine training systems. And before I get started here, just want to review, what is important from your standpoint as people who grow the grapes, and why do we look at different training systems. Of course, the first thing is that we're looking at performance. How many grapes can you produce in different training systems, and does this vary by training system? So yield is important because most of you who sell grapes get paid or make wine. You get, the absolute quantity matters, but that's not the only thing that matters. Quality and the fruit chemistry and wine quality also matter. And I guess everybody is familiar with the concept that low yields equals quality. That's not necessarily true, as we'll see, but there is certainly the potential for overcropping grapes and reducing the quality. For me, with many of the hybrid grape varieties, and including these, we don't know enough about how yield affects wine quality to really make any very confident statements about that. But we can measure fruit chemistry and see if the practices we have affect that fruit chemistry. And in particular, with these grape cultivars, it's very important to manage acidity, and because high acidity is a problem or an issue with these varieties. And so if there are things we can do in the vineyard to manage the acidity, even if we reduce yield through training system or the number of buds or by cluster thinning or whatever, that might be worthwhile. So the third thing, though, that is really important is the cost and the labor inputs involved in managing your vineyard. And so I guess it comes down to you get paid on the amount of grapes, so you produce wine based on the amount of grapes you have. You want a certain quality from those grapes, and at what cost can you do this? So I'm going to jump right to the conclusion here and talk about our Marquette and Frontenac trials. 2012 was a frost year, but 2013 we got some pretty good yields. So in our Marquette and Frontenac trials, we compared top wire cordon, cane prunes, umbrella to VSP, and both of those systems produced more grapes, provided similar acidity and pH, and slightly lower Brix, but based on the cropping level. And both of them are things you can do at a low cost and less labor, and I'll get into that in a moment. But I just wanted to jump right to the conclusions here because I think it's a fairly simple story we have, at least with the data that we have. And I want to start out with annual growing costs per acre, just to set the stage, because I think this is a good framework to think about it. So if you look at fixed and variable costs, fixed costs, if you have a 50-acre vineyard, are about 40% of your growing costs per acre that you have to generate revenue. If you have a 25-acre vineyard and you spend the same amount, then that's $2,800 per acre versus $1,400 per acre. But the variable costs, the costs that are associated with things that you have to spend money on each year. We look at materials, that's about 20% of the growing costs. Equipment, tractor use and so forth, that's another 20%. So all your inputs and labor, that only accounts for about 40% of your variable costs, and labor is a big chunk of this at 62% of your annual costs. So in as much as you can reduce the labor input, that's a big area to look at for being cost effective in your production practices. So I'm just going to go through this rather fast because I only have 20 minutes here. But we looked at 3 training systems, and here's the wires that just came up just to sort of orient you to the 3 systems, and here's what the trunks look like in those 3 systems. So I'm going to go through them. Vertical chute positioning, most of you should be familiar with. We used a mid-wire cordon with movable catch wires. We did a lot of canopy management, including chute positioning, chute tipping, and leaf removal. And I'm calling this our intensive canopy management system. So that's trained to the mid-wire. The top wire cordon, again, this is a high cordon. And we didn't really do anything like chute tipping or leaf removal in this. We just went through one time and did downward chute combing, and I'll show you a picture of that in a moment. So that's the only thing we did to manage this aside from adjusting the chute number. So all the chute number was the same in all of these. So this is a moderate canopy management. And umbrella niffin, I chose that because I haven't seen much cane pruning with these varieties. This is something that's commonly used in the Finger Lakes with natives, and also with most of our vinifera is cane pruned here. So here we just have the arched canes that are arched over the top wire and tied to the middle, and we didn't do any additional canopy management. So this is our minimal canopy management system. So here's just how they looked in June and May. And you can see by the end of the season, or late in the season, after the canopy had developed, you can see a lot of differences in these vineyards with the VSP in the foreground, and then I believe that's the top wire cordon in the middle ground there. Just to go through briefly the practices, this is Chrislyn and I moving the catch wires. So we had only one set of movable catch wires that we used to constrain the canopy on the VSP. But we did that certainly a couple times during the season. Shoot tipping and basal leaf removal. We did shoot tipping at least a couple times. As you can see from these photos, we didn't do it in a very timely fashion. The vines seemed to grow too fast to really keep up with it. But we were shooting for about 3 feet of canopy and shoot tip the things. Leaf removal, we did this twice in the VSP, once on July 10th. You can see it on the top there. And then we had to go back in August and do it again. And the reason for that is because we got a lot of lateral shoots, which you can see here growing down. And those grew in and completely reshaded the fruiting zone. And so we did removal on those and exposed the clusters again. On the top wire cordon, and we did this a little bit probably too late. It would probably be easier if you did it earlier. But this shows a Frontenac before and after, and you can see and basically just pulled the shoots so that they're, combed them so that they're pointing straight down instead of growing across the canopy. And you can see the difference in fruit exposure in the before and after scenes here. So that's the only canopy management we applied to the top wire cordon. And again, this would probably be easier if you did it maybe in late June or early July. So manage these all years, and then we harvested them, looked at the yield and the yield components, and collected berry samples for testing fruit composition. We also collected pre-harvest samples. So I'm going to cut to the chase here and I'll start out with the Marquette. And here's some fruit that we got from individual vines in 2 different locations. You can see there's more fruit in the umbrella nippon in the top wire cordon, VSP, and the VSP. If you look at the clusters, representative clusters, you can see some difference in cluster size there. But this was quite dramatic. And I'm going to show you here the yield from 2012 and 2013. 2012 was okay, very good, this works. 2012 was a year in which we got frostless, so the yields were quite low. It was also a year in which we were converting some of the training systems to the high wire from the low wire. So basically we had some differences in 2012, but very dramatic differences in 2013, where our VSP yielded slightly over 2 tons, or 7 pounds per vine, and our top wire cordon and VSP yielded more. And I'm going to go through that in detail here on the next slide. So I want to go through the different yield components, of course, because your yield is made up of several different components, and training systems can affect different ones of these, different sections of these differently. So here you can see our yield in pounds per vine, 13 in the TWC, 16 in the umbrella, and 7 in the VSP. So what made that happen? Well, a big contributor was that there was fewer clusters per vine, approximately 70 versus 80. And if they have a letter behind them, that means that they're statistically significantly different. So we had fewer clusters per vine. The cluster weight was pretty dramatically different, 50 versus 75, about 30% smaller. Berries per cluster were fewer. And again, this was consistent both in 2012 and 2013. If we ignore the yields and just look at the yield components there. And even the berry weight was significantly lower. So this is kind of surprising and a very dramatic effect that I'm still looking around for a hypothesis as to why this happened. One hypothesis might be that the buds were shaded the previous season and so were less fruitful. If we look at the TWC versus umbrella. So umbrella had slightly more shoots per vine. And if we look at this other measure, which we call yield per shoot, another name for that is bud fruitfulness, we can see that both of these, TWC and the umbrella, were equivalent if we look at it on a yield per shoot basis, whereas the VSP was about half as much. Okay, and this is just an example from two different places. On the left, this is from our trials. We took the TWC clusters, and then I put some VSP in the same shot there. You can see the clusters are a lot different. And then, okay, I can hear somebody talking in the background here.
Yeah. Marie, could you please make sure your microphone stays muted? I keep having to mute it, and we're getting a lot of background noise coming through from you. Thank you.
Okay, the one on the right is I made a visit to Pennsylvania in the Endless Mountains regions, and there happened to be a grower there that had half a row on top wire cordon and half a row on VSP. And this is how they looked sort of right around duration. Believe me, I didn't cherry pick that cluster. It was the whole vines looked that much different. So it looked like the VSP in that situation was delayed in duration, and the clusters were definitely smaller. If we look at fruit composition, the main difference we see in 2013 is higher bricks, 25.5 versus 27.5. That's 2 degrees bricks difference. And considering the dramatic difference in yield, that's sort of what you would expect when you have twice as much fruit on a vine, is that you're going to get somewhat lower bricks. pH was moderately higher on the VSP in both of the years, but I want you to look at the titratable acidity, and that was absolutely identical. So my takeaway from this is that even with half the crop, we didn't see any influence on the titratable acidity in that case. So reducing the crop through this training system is probably not the way to really influence titratable acidity. Going to move on to Frontenac. I'll go a little quicker here because we have similar effects but a lot less dramatic. Here you can see that the VSP was significantly different from the umbrella. TWC was sort of intermediate. Here you see the trends for both years, but so this is 4 tons per acre versus 5 tons per acre, or 12 versus 15 pounds per vine. So if we look at the yield components, slightly fewer but not significantly fewer clusters per vine. Slightly lower cluster weight, but not significantly lower. Somewhat fewer berries per cluster, but higher berry weight. So all those things are very modest effects, but if you add them up, then you can see that when we get to our bud fruitfulness measurement, that's yield per shoot. We're looking at 167 grams versus 200 grams in the umbrella and 180 in the top wire cordon. So modest effects, not as dramatic as the Marquette, but they're nonetheless. Fruit composition, I'm going to just tell you that if you look across all these bars, you can see some modest differences in these. Slightly higher pH again, but certainly no bricks effect and no titratable acidity. Basically, all of these treatments, if we looked at them as a whole, had very, very similar and not very different fruit composition, not measurably different. But I want to go through and look at something different. While we were harvesting this, I remember that we had guard vines on each end of the block, so I decided to harvest some shaded and exposed clusters. So I got 5 pairs of shaded versus exposed clusters on all the different training systems, and we took those to the lab and did analysis on them and compared the fruit chemistry on the exposed and the shaded. If you look at the graphs down below, the exposed clusters are the blue bars and the red ones are the shaded clusters. So berry weight, sort of a wash there, but I want you to look at the bricks here. And this is across the training systems. The exposed clusters had about 2 degrees higher bricks than the shaded clusters in the umbrella niffin and the VSP. If we go back to the top wire cordon, we see sort of a similar thing, but you can see that even the shaded clusters there had the bricks wasn't all that different, and I attribute that in part to the shoot combing that we did. And then the other big difference was in titratable acidity. If we looked at shaded versus exposed, the exposed clusters had 2 grams per liter less titratable acidity than the shaded ones. And again, that effect was muted somewhat on the top wire cordon. So that is getting me excited about the shoot combing aspect of this, and interested in seeing what we come up with this year. So just want to very briefly conclude this, is that both of our high training systems, the top wire cordon and umbrella niffin, had higher yield in 2013. We'll see if that continues into 2014. But it was very dramatic in the case of Frontenac, or Marquette, and less dramatic in the case of Marquette. The higher yields in the Marquette, keep in mind that we're talking about double the yields, lower the bricks, but there was no effect on titratable acidity. And then regardless of the training system, on Frontenac, increasing the fruit exposure is the thing that helped minimizing the acidity. It wasn't the training system per se that did that. It was minimizing the fruit exposure. So what are the ways to do this? Well, in my mind, shoot thinning is the first step, and that's the least expensive thing to do. If you do this very early in the growing season, when the shoots are, say, 3 to 6 inches long, you can go through and do it very fast, and that's sort of the first cut for me. The downward shoot combing, that's not exactly a simple thing to do when you do it in August. It was pretty time consuming, but I believe if you did it earlier in the season, it wouldn't take quite so much time. The final point I want to make is that we all have to shoot for economic sustainability. So what is a good target yield for these cultivars? And I would have to say that at the prices, say $1,200 to $1,500 a ton that you're getting, and the size of the vineyards that you're growing, I don't think there's many 50-acre growers out there. 10 pounds per acre per vine, which would be equivalent to 3.1 tons per acre at 622 vines per acre, is really a reasonable kind of low end of the yield target that one should shoot for. And Paulo's going to present some different information about this too. But I want to go back to these annual growing costs and keep in mind that if you just consider the variable costs, that's about $2,200 a year. But looking at the total cost for the 50-acre vineyard or for the 25-acre vineyard, then if you get revenues of $1,200 per ton, if you're looking at $3,600 with fixed and variable costs, you're going to need more than 3 tons per acre at that price. If it's more than, if it's a higher fixed cost, then you're going to need even more. And I think most of the people that are in this audience are looking at that lower figure because of your vineyard size. So that's something to keep in mind as you look at things. Final point I want to make is these costs I presented were for VSP. If we look at top wire cordon, you're going to have lower labor costs, and we sort of estimate that at about a 35% savings in labor for doing this top wire cordon in limiting the canopy management. Just a final point here is, and this is from our vinifera cost study, if you look at canopy management, it's certainly a huge chunk of the labor hours. In our studies, even more than pruning. You know, the rest of the things you do, spraying, floor management, suckering, and tying are have a less of an impact on costs than the canopy management. So I want to just close with this one slide here. This is Daniel Gomez. He worked up at Coyote Moon Vineyard last year. He's back this year. He's from Portugal, and this is what he came up with as an idea. Downward shoot positioning, and then he does have some catch wires there so that canopy is constrained. And then they have a hedger that goes through and gets all those laterals that come out. So so that's something maybe to consider for the future. And that's where I'll stop. Thanks for your attention.
Okay,
So,
Tim. Yes, we have several questions. The first one is from Rick that's actually related to getting the project renewed. He wants to know, is there anything we can do to help write our congressperson?
Absolutely. Certainly you can write your congressperson. And we're going to be actually submitting this. The deadline is June 20th. So we are asking all of your state and local vineyard associations to write us letters of support that we can include with the grant application. But if you like, if you like what we do, it certainly wouldn't help to write your congressman and say, well, the Northern Grapes Project has been very useful to me, and I really like this program and this project.
Okay, we had actually a lot of questions. I don't remember. Nielsen Family Vineyards asked what was the age of the vines in the trial, and for the life of me, I can't remember when that was planted.
Yeah, they're about 6 years old.
Okay.
Now this and year. Then so year 5, year 4, and year 5 I believe.
Okay, and then Al had asked what was the row and vine spacing, and I was able to answer that, which is 7 by 10. So just for everybody else out there who wanted to know. Greg Cook asked, comments that the differences in TWC versus VSP are quite interesting. I'm wondering if anyone out there has any experience with GDC, which is Geneva Double Curtain.
I think stay tuned, and I think Paolo's going to talk about that.
All right, and then Patrick said the umbrella niffin system seems to have performed very well, but how about harvesting the fruit? With top layer cordon, the fruit would more or less be concentrated in one zone, and with umbrella niffin, the fruit might be more spread out and hard to find. Do you find more labor is required to harvest the umbrella niffin fruit?
There might be slightly more labor involved, and I guess that's something that I often forget about because most of our fruit here in the Finger Lakes is machine harvested. But yes, I think there's modestly more labor involved. It's not a huge difference because the cluster zone, instead of being say 1.5 feet, it might be say 3 feet. So I don't see it as a huge impediment. For some people, having the fruit up high instead of low is an impediment because they have to reach up to harvest the fruit. But no, I don't see it as a huge deal. It's when you get into things like mechanical pruning where you leave a lot more buds and then you have smaller cluster that it's possible for us when we do it to machine harvest the fruit, but it'd be very hard to hand harvest.
Yeah. Then Greg Cook asked, how do you think soil richness, high nitrogen, and high pH above 7.5 would affect this?
Yeah, well, fertile soils will grow bigger vines, and I believe this is certainly an issue in the prairie soils in the Midwest, where you might have 5–6% organic matter, and the soils will supply a lot of nitrogen. They'll grow big vines, and so it's going to be your job to manage those, and whether it's by dividing the canopy using GBC or having longer in-row vine spacing, so fewer but bigger vines. You know, there are ways of dealing with it, but I realize it's a challenge. And I don't have any experience with the high pH soils, so I can't really answer that. Maybe Paolo can.
Okay, and this is a little bit different. Involves a different cultivar. Tom from Eagle's Nest asks how similar and different are Regent and Marquette. Says that he's testing both and is looking at blending the two wines and wondering if Marquette is more desired.
I really don't know how to answer that question because I have absolutely no experience with Regent. Regent is a variety from Germany that is classified in the European Union, even though it's a hybrid, as a vinifera type. So I'm assuming that the fruit characteristics might be a little different, lower acidity and so forth. But I don't know anything about very much about that. Maybe Paolo can comment at some point too.
Okay, and then Al asked, says that side netting for birds is essential in our vineyard. It is relatively easy and low cost with VSP. How easy or difficult is it to net the top wire trellises compared to VSP, and how does the cost of netting materials and labor compare?
Yeah, you definitely can't use the side netting, but all these vineyards were netted, and they used over the top netting. So I guess it'd be the difference between applying the top netting and the side netting and over the top netting. I don't think there's much difference in the material cost for that. I know it helps with the over the top netting if you have some sort of a apparatus on your tractor to unroll and apply the netting. Okay.
Okay.
So should we turn it over then? I can't hear Chrislyn.
Oh, sorry, I was muted. I'll send the questions that came in that we didn't get to answer. I'll send those to Tim, and maybe he can work on answering them in the chat pod. Or we'll figure out sometime. But anyway, we'll get your questions answered, guys. So, Paolo, let me get you set up so that you have control of the slides. Where are you? Sorry, guys. This takes a little time to get set up sometimes. So,
okay,
all right,
thanks for your
Paolo?
attention. I'm going to mute.
Okay, Paolo, we're all set up if you're ready to go.
Okay, thank you, Chrislyn, and thank you for inviting me. I think it's a great opportunity for me to share some of the work that we're doing in Michigan, at least in the last couple of years. And I totally agree with Tim that 2 years doesn't tell you a lot, but I think it's very important to share with you what we have and what we're thinking to go after this. Before I start my presentation, I really want to thank you, a lot of different people. First of all, Tim and Chrislyn, they're doing a fantastic work in managing this grant, and it's a really a pleasure to work with them, and I'm feeling fortunate that I was able to be part of this group, and the funding I received from the USDA I used mainly for supporting a student, a master's student, Jack Hemming, that will finish the thesis very soon. So I'm very happy to be part of this group, and I'm happy that we will be money also from Michigan State, some matching funds to do some work in the vineyard, and we did a lot of work at the Southwest Michigan Research and Extension Center in Frontenac here. in East Lansing, in the main campus, where we have another experimental station. And we had a couple of wineries that were involved with the project. Flying out the winery, I want to thank you, Bob, for being part of the project, and also Megan. They shared the vineyards, and we did some experiments in the vineyards. We show you some data also on the wines that we made from the different experiments that we did in the last couple of years. So I want to thank you all the people that came in the department to be part of the sensory panel, and I will show you some data that we got after testing the wines. And I will have only 20-25 minutes today, so I will share just a few data and important points that I think the most important thing that we learn working with these super hardy varieties in Michigan. But if you are from Michigan and you have an interest in seeing the full story of this project, you can come next week, Tuesday, to see the presentation of Jake Emily. Jake was the student that was supported by the grant, and he's defending his master thesis next week. So it will be 1 p.m. If you want to come to the Department of Horticulture, you're more than welcome to join the seminar. We did experimental work in 3 locations in Michigan, the Southwest, and here in East Lansing, as I said, and we did also experimental flying out a vineyard in Adrian. And we have 2 years of data, and I will show you some data about the trellis system and the crop load from 2012 and 2013, and a little bit of also data from the sensory analysis of the wines. I want to talk a little bit in this time a little bit about Marquette, why we think Marquette is important for Michigan, and how this variety is helping us to expand the grape industry in Michigan, and work that we did on the trellis system. Like Tim Martinson said, trellis system very important. And why we choose to work on trellis system, because these varieties that tend to have high sugar and high acids, so we're always looking for a way to really harvest the fruit that will have all the basic fruit chemistry parameters in balance for making very good wines. And working on the trellis system is the most important and efficient way to change fruit chemistry parameters at harvest. 2012, I'm going to show you some data on the weather and the frost. It was a very, very particular difficult year for us in Michigan, all over the Midwest, with a very early spring, so we got frost. And the frost gave us the opportunity to study a couple of different things that we were not planning to do. And thanks to Jake, he had a good ideas to how to use the frost and study how Marquette responded to the frost. And I will show you the data from 2013, when we did a little bit more work on crop load and adjusting the level of yield on the vines, and trying to see which is the impact, or different way to reduce the upper vine and the impact that we have on cluster microclimate and fruit quality at harvest. As you probably know, in Michigan we have 15,000 acres of grapes. More than 80% are juice grapes, Concord and Niagara. I want to show you the table that you see over here, because you see a huge revolution that happened in Michigan the last 11 years from the USDA survey. So we had in 2000 we had the same amount of hybrids and vinifera, 5% of the total acreage, 660 acres of hybrids, 640 acres of vinifera. In 10 years we had a revolution. The planting of vinifera went up 3 times, so now we have 12% of the total acreage of grapes in Michigan that belongs to the vinifera group, and the hybrids did increase a lot, so still 5%. So if you take a look at the numbers, in 10 years we planted only 64 acres of hybrids in relation to the more 1,000 acres of vinifera. The 2011 report, USDA report, is telling us that we have only 12 acres of Marquette in Michigan, but we are working with a lot of different growers in Michigan. We know there are more than 11, and we count around 25, so it's not a lot. But if you think about the last 10 years, when Marquette was introduced in Michigan, and the 64 acres of hybrids that were planted, 40% is Marquette. So it's a pretty large number of hybrids of planting that belongs to this variety. And if you see the graph on the bottom of the page, this is data that we recently published. And because we had three times the amount of vinifera than we had 10 years ago, when you study this in relation to other states in the east and the Midwest growing grapes, we are in Michigan the one that's a higher ratio between vinifera and acreage. So we have more vinifera and acreage than any other state. So I think Marquette plays a very important role because yeah, we are focused on vinifera now, but in the planting of acreage, Marquette is 40% of the planting. So it's not a lot. It's only 3% of the Marquette represents 3% of the acreage of wine grapes that we have in Michigan, but I think it will play a big role in expanding our industry, especially in areas in which the focus cannot be vinifera for problems related mainly to the weather. So we did a study in which we choose 3 different training systems, like Tim did in his presentation. We have 3 different training systems. The classical one, the high-wire cordon, is the most used in Michigan for growing Marquette and hybrids. The Geneva double curtain, so this system which you split horizontally the canopy, so you have a bigger canopy and you can crop a little bit more. And the first training system is an experimental system that we tried with Jake in Michigan because we were very curious. And coming back to the idea of using training system to change fruit quality, this training system that combine the effect of the VSP, but it's a split VSP in which you have a 2 VSP system that you can open and close. So it's a canopy you can fold and unfold. So when you fold, it's like a VSP, but when you unfold, it's like a GDC, just vertically. Was a very interesting. There is a very interesting paper also in the literature, recent publishing, which there was a huge effect on this training system on changing the fruit quality of harvest, especially in relation to acid degradation. That's a problem for harvest that tends to have very, very high acidity at harvest. So let me talk a little bit about the spring of 2012, why it was so different and was so challenging for us. On the right, I don't know if I can use an arrow here. And on the right here, you see the growing degree days of the last 10 years mean and what happened in 2012. We reached more than 200 growing degree days very early, at the end of March. And when Marquette reached 200 growing degree days, started to grow. So bud break was very, very early. We had bud break at the end of March. And on the other side, you see the temperature. So after bud break, we have 5 times which the temperature was below 32. So we had 5 freezing events after bud break. So you can think about that the grapes the vines were really pretty damaged. And when you take a look at Marquette here below, and you consider the time of bud break also in a normal year in Michigan for the historical series of data that we have, Marquette is the variety that we are growing in Michigan that tends to bud break first in relation to the other one. After 3 days, we are present. Frontenac 8-9 days after Marquette, Concord a couple of weeks after Marquette, and all the vinifera they tend to bud break between 20 and 30 days after Marquette. So Marquette tends to bud break very early, and a bud break very early in 2012. So the results of this was the frost. And you can see here a picture of Marquette after the 5 frost event. Pretty beaten up, and we were pretty discouraged by the effect of the frost on the vines. But as you know, vines have this very interesting system of using the compound bud to recover from frost or any kind of damage. So we have always a secondary bud pushing after the primary buds is dead or compromised by the frost. And it's very simple to recognize if the shoot is coming out from a primary bud and secondary bud, because the secondary bud tends to come out at 90 degrees from the canes. So when you go in front of the vines, you immediately recognize if it's a shoot from a primary bud or it's a shoot from a secondary bud. That was the work that Jake did. He was able to characterize different canopies of Marquette vines in relation to the frost event and follow the growth of shoots on primary and secondary buds and follow the growth of clusters on primary shoot or secondary shoot. And it was very interesting, and I will show you the results, what happened after the frost. So the 3 training systems have the same amount of buds. There is a trend having a little bit more buds in the movement trailing system. But the frost, when you see the percent of primary buds, they eat the vines in the same way. So we had only 20% of the primary buds alive, and it was the same for all the training systems. So we needed to work with 30-40 buds. Not too much, as we would like to have, but still a number of primary buds to have a decent crop. And when you take a look at the phenology, CPS is clustered on primary shoot, CSS is clustered on secondary shoots. The phenology was really different. So the cluster on primary shoot have a very early antithesis and the entering period 180 days after bud break, and we harvest 143 days after bud break. The cluster on secondary shoot, they lag behind a little bit, around 1 and 2 weeks during all the phenological stage, but we harvest the cluster on the same days that we harvest the cluster on primary shoot. So there was a lagging behind in phenology of this cluster, but we harvest the cluster at the same time. And it's very interesting from a phenological point of view that this variety tends to ripe very early in Michigan. I will show you some data about that. But if you just take a look at the time from variation to harvest, it's less than 30 days. And we don't have any other cultivar in Michigan. It's around 25 days. We don't have any other cultivar that can ripe so early in Michigan after variation. So it's a very, very early ripening for us. Here you have the berry diameter, again, the growth of the berries they were on cluster on primary shoots, or the grow the berry, they were on cluster on secondary shoot. And you see the secondary shoots, the cluster on secondary shoot, they are lagging behind at the beginning of the season, so there is a phenological delay in the development of these berries. And when you get to the end of the season, the berries they have the same size. The same for the sugar here on bricks. You can see the cluster on primary shoot, they tend to have statistically a little bit more sugar at the beginning of the fruit ripening, but when we get to the harvest, this difference disappears. It's the same for color compounds. So these berries, after variation, they tend to have the cluster on primary shoots more color compounds, especially at the beginning of the berry development and ripening. But when we get to the harvest, the difference disappears. So the cluster on secondary shoots, they have a delay, but they can catch up during the season until harvest. So some data about the quality and the yield. We didn't see any difference in yield in relation to the 3 different training systems. Cluster number was the same, cluster weight the same. We didn't see really difference in the components. And pruning weights, they were in the range that they should be for this variety, pretty vigorous, so more than a couple of pounds per vine. With the Ravat index, that's the ratio between yield and pruning weight, very low. So because of the frost, we didn't have a lot to yield, and so the Ravat's index was very low. And I will show you the Ravat's index for the following year when we didn't get any frost. When it came to fruit quality, with the same amount of yield, the GDC vines, they had a higher level of bricks, 10% more than the other 2 training systems. And there was also an increase in phenolic compounds, 15% more. Now, we harvest the vines the first week of September, so we had a lot of time to ripen the fruit. So probably with extra hanging time with the 2 other training systems, we were able to reach the same amount of bricks, the same amount of phenolics or the GDC. But at the time of harvest, that's what we found. The GDC seems to be a little bit more efficient, the same amount of yield, to have a little bit higher phenolic compounds, a little bit higher sugar accumulation. We didn't find any difference in color compounds. When we did the separation of the fruit quality of cluster on primary shoot and cluster on secondary shoot for the 3 different training systems, what we found is that most of the yield was on secondary clusters. So 9-fold of the yield was on secondary clusters, a huge difference. But not a lot of other difference, like I showed you before. There is a trend of having bigger cluster on secondary shoots. And this is not usual. In general, cluster on secondary shoots, that tends to be smaller. There is a trend on seeing bigger cluster on secondary shoot, and I think this is an effect the frost that we get early in the season. So probably the primary bud had the cluster compromised by the frost and the fruit set was reduced, and in the way we had a little bit bigger clusters on secondary shoot because they grow, and the fruit set was at the time which the weather was not a limiting factor. And you can see also the berry per cluster that was affected by the cluster. When it came to the fruit quality, not a lot of difference. I think the GDC are confirming that the clusters on primary and secondary should have the same amount of sugar. So the Brix was the same. There is a trend of having less sugar in cluster on secondary shoot for the other two train systems. So the GDC were confirming to be the better train system for having more uniform fruit between the primary and secondary shoot and the higher level of sugar at harvest. And when it came to the sensory analysis of the wines, we used the GDC, but the same trend was also similar for the other train system. So here we are comparing the wines made with the fruit coming from GDC train system and keeping the separation between the fruit coming from primary shoot and secondary shoot. So Jake made the wine keeping the separation of the two different population of fruit. We saw difference in color intensity with the cluster in the primary shoot having a little bit more color than the wines made with cluster coming from secondary shoot. Not a lot of difference in aromatics, but pretty interesting difference here when it came to the test. The wines coming from fruit from a primary shoot, they show a little bit more body, higher acidity, and a little bit more astringency. So what we think about this first year, I think a couple of preliminary conclusions I can share with you is that the frost event, also if we had three different train systems impact in the same way the three different train systems. We didn't see any difference in relation to the three train system in relation to canopy growing size. Basic fruit chemistry on cluster on primary shoot and cluster on secondary shoot was very similar. The difference were due only to the fact that the cluster on secondary shoot had a couple of weeks of delay in phenology, but they were able to catch up at the end of the season. With 80% of the primary buds killed, we were able to crop around 2 tons per acre. And it's the most interesting thing I think that came out from this experiment is that, yeah, we didn't see a lot of difference in cluster coming from primary and secondary shoots, but when we went to the winemaking, the sensory analysis, the panel were able to pick a lot of difference between the wines, especially not only the color, but especially when it came to the body and the stringency of the wines, so a little bit better mouthfeel on the wines produced with cluster coming from primary shoots. So in 2013, we really focused on crop load, and we did a lot of experiments in the Southwest. We did a shoot thinning experiment using the three train systems, and we did a crop load experiment reducing the amount of yield with cluster thinning of fruit set using high wire cordon vines, the classical train system used for Marquette in Michigan, and that's what I will share with you. Just the effect of cluster thinning on high wire cordon vines. And the objective of the study was the classical objective that any viticulture person has in mind every time you think about experiment, is this interaction between canopy growth, yield levels, cluster exposure. What happens when we change these important viticulture factors in relation to the fruit maturation at harvest. So we should. I'm not aiming here for giving you suggestion how to crop the vines. We designed the experiment really to stress the vines, to see the effect of crop load. So every time we do an experiment, we really want to stress the vines at the level in which we can see difference and fine-tune after. So this first experiment was really an experiment designed to stress the vine as much as we can. So when you see high level of yield here, we are talking about almost 14 tons per acre. So it's a lot of fruit in relation to 6.9 tons per acre, 7 tons per acre. And this was achieved leaving different number of clusters per vine. As I said, we reduced the number of clusters per vine at fruit set. So we go from 264 clusters to 114 clusters per vine. With this huge difference in in tons per acre yield per vine cluster number, we didn't see any difference in other yield compounds like cluster weight or berries per cluster. So the yield per vine did not change any other fruit parameters like berry weight or number of berries per cluster. And there is a reduction in pruning weight. So when you have a very high yield, high yield per vine, you can see that the vines are struggling a little bit, but not too much. We are still talking about almost 2 pounds of pruning weight. That's a pretty good number in relation to 2.5 pounds of pruning weight per vine. So yes, vines growth was reduced, but not so much. And when it came to the fruit quality, we saw an impact of the yield per vine or sugar accumulation. Yes, when you have a low yielding vines, you can reach very high level of bricks. And we went 25, almost 26 bricks in low yielding vines in relation to 22.4 in high yielding vines. Not a lot of difference in other parameters. Very interesting for me was we didn't find difference in phenolics and anthocyanin compounds, and I will talk a little bit more about this. We measure in a very detailed way light and temperature at the level of the cluster. So we have this system set up in which we have sensor for light and sensor for temperature at the level of the cluster, each single cluster, and we have sensor for measuring environmental conditions, so light, temperature, humidity. We record this from fruit set to harvest, and what's the way for us to really follow what's happening at the level of the cluster in relation to the different yield per vine that we have in this experiment. So when you take a look at the canopy architecture, here on the right you see the shoot length. We measure the shoot length weekly, so until the end of the season we measure leaf area per vine, we measure pruning weight, so all the parameters that go in the same direction. The more you increase the yield per vine, the more you decrease the shoot length. So when you start to put 22, 24 kilograms of fruit per vine, you get a reduction of around 30–40% of canopy or shoot length or canopy size. And what happens when you have this this reduction in canopy size? Happened that the cluster that were here I need to apologize because there is a problem. This yellow one is not low, but it's high crop load. So when you have a very high crop load, in this graph you have part that is the light that we can measure at the level of the cluster during a day, and this is a mean from variation to harvest. You see that a cluster that is on a very high yielding vines, that the same amount of light that a cluster that has the same amount of light that you can measure in the environment. So that means that this cluster is completely under the sun during the day. While the clusters they are on a bigger canopies, so with a medium and low low level of crop load, they are in the shade during the day. So the big canopy, due to the fact that we had a very low level of yield for this experiment, they were trapped inside the canopy. But when you start to reduce the canopy size with a very high level of yield, you put the cluster under the sun. And when you put a cluster under the sun, we know that a lot of things will happen, and I will show you what happened. So just to give you a little bit of conclusion about this experiment, what we think, increasing the yield per vine, we saw a reduction in sugar accumulation, and this is a classical one. Sugar per vine, it's really driven by the fact that you have a bigger or smaller canopies, and it's really driven by the photosynthetic level of the vine. So if you have a very big canopy in relation to the amount of fruit that you have, you tend to have a very high level of sugar. If you increase the yield per vine, the same canopy cannot fill all the cluster on the vine, so you tend to have a very low level of sugar. It's not very low for us because it goes between 22 and 27 bricks. So but at the same time, showed the point that increasing the yield per vine, you reduce the sugar accumulation. But in the second graph in B, you see that increasing the yield per vine doesn't have any impact on phenolics and anthocyanins. In general, these compounds, they're not really related to yield per vine. They're more related to the microclimate condition in which the cluster were during the season, and they're mainly related to the amount of heat and light that the cluster is able to intercept during the season. And when it comes to seed, that's the classical problem that we have right now, especially with the super hardy variety. When you see the increase on breaks in relation to the yield per vine and the color compounds accumulation in this cluster, they're not really correlated. They are not really coupled, and this is something that we don't want to see. In general, we would like to see that the sugar increasing the sugar accumulation, we're able also to increase other compounds in the cluster, and color compounds are very important. So they are not really coupled in this experiment. But in the shoot thinning experiment, which we were able to change the yield per vine at the same time changing the cluster microclimate, we were able to couple a little bit more the accumulation of color compounds during the ripening of the fruit. So some conclusion about 2013. Yield per vine was huge, the difference between 13 and 6 tons per acre. Didn't change a lot of different things. For sure, changed the sugar accumulation, and it changed the canopy growth. No other components was impacted. We had the same cluster size, the same berry size. But the most interesting thing, and will be the direction of the future research that we are going. When we put on the vine 13 tons per acre, we were able to reach 22 bricks. And because we reduced the canopy density about 30% in relation to the low-yielding vines, we were able to bring down the TA, the acidity of the vine, of the grapes, to almost 7 grams per liter. That's a pretty good level of acidity for Marquette. And if you do the ratio is 3.3, so any winemaker will tell you that this is a pretty good ratio for making very good wines. And I think because increasing the yield per vine, we were able to slow down the sugar accumulation. And slowing down the sugar accumulation, we gave time to the vines to really metabolize the acidity to levels in which we would like to see the acid when it comes to harvest time. When and how manage the Marquette canopy is my next step. I hope this grant will be funded also in the future, so I can do a little bit more work on that. I can see some very good results from the shoot thinning trial, but it's not enough to really give you conclusion about how to manage the canopy. So let me conclude here just sharing with you what I think we learned this year. First of all, we learned that Marquette is very prone to frost. There's a pretty good production on secondary, but remember the bud break is a couple of weeks before Concord in Michigan and the Southwest. Concord gets a frost every 3 years. So when we think about Marquette in the Southwest of Michigan, when you really think about the problem of frost and maybe work in avoiding a lot of damages. The secondary are very productive, and the fruit quality is pretty good, especially when you compare a cluster coming from primary shoot to secondary shoot. We didn't see a lot of difference. And the other very important thing that we learned is Marquette ramps very early for Michigan standard. In the 2 years we harvest between the end of August and early September, and it's 40 days before Cabernet Franc, 20 days before Pinot Noir. So in relation to the classical red vinifera cultivar that we have, it's a very early ripening. So when it comes to hanging time, and maybe changing the fruit quality harvest using hanging time that we cannot do with any other vinifera grapes because we don't have hanging time in October, but we have a lot of hanging time in September that we can use, and that would be very important, I think, to understand a bit better how to manage the fruit quality harvest. So very early ripener. And Marquette seems very resilient to viticulture practices. What I mean, we changed the yield a lot, and we changed the train system. We didn't see a lot of difference at harvest. So I guess that the most important future activity will be understand a bit better the canopy management. Is there where we can have a huge effect, and I'm not sure if Marquette is a more Pinot type or a more hybrid type. If Marquette is a Pinot type, when it comes to canopy management, doesn't need a lot of light and temperature. If it's an hybrid type, it will need a lot of light and temperature, So we'll change a lot the timing of shoot position or leaf pulling. So if it's a phenotype, we cannot do a very aggressive leaf pulling or shoot positioning because we'll suffer of too much light, too much temperature. It's a more, if it's a more an hybrid type, yeah, we can really put the cluster under sun by the end of the season using train system or current management technique. And the last point I want to share with you is that, yeah, we didn't find a lot of difference in the vineyard. I tried to give you an interpretation of the difference we found, but remember they were very minimal and often not really statistically different. But all these very tiny difference had a huge difference on wine sensory analysis. So the panel of people that came for testing the wines that we made from this experiment, they were able to pick out the different treatments. So it's very tiny difference in fruit quality between primary and secondary cluster or training system. There were huge difference on wine sensory analysis, and we have a fantastic group of people in this of enologists in this proposal that I think they can share with you some of the most important reason why. Also, if you don't change basic fruit chemistry, you change a lot the sensory analysis of the sensory perception of the wines when you made from grapes coming from different treatments. And with this, I think I'm done, and I'm open to any question you can have. Thanks a lot.
Okay, we did have some questions, but since Jake was online, he was able to answer some of them. So thank you, Jake, for doing that. We really appreciate it. So let's see here. Dennis Strumman commented that interesting that in Michigan, top wire cordon is a cane tied down versus the one in New York is two-bud and combed. And here in northern Minnesota, it's not as vigorous as it is in Michigan. So,
yeah, that's a good comment. You know, and every place you grow grapes, you expect different response. So my data different from team. Also, if the conclusion are very similar because we are growing grapes in different environment. We have a very sandy soil in the southwest, but we have a lot of rain. So vines that tends to be very vigorous, not because we have a very heavy soils or very rich soils, but just because we get a lot of rain, and especially in the spring. And this rain that tends to push the view pretty early in the vines, and we have very long shoots. And I can give you an example. Sometimes in Michigan we're edging VSP vines, vinifera VSP vines before bloom, and that tells you how much vigor we have in Michigan when we get very wet springs.
Okay, we had a question that was actually asked to Tim, but he's passing it to you, Paolo.
Okay.
David Pop asked that he's interested in the effect of high pH on Frontenac. His soil pH is up near 8.
I think he's referring to wine, and I can't answer to the question very well. You know, every time.
Oh no, I'm pretty sure he's talking about his soil pH because later on he said that he's got some other problems in the vineyard too. So yeah, he's talking about soil.
We don't have any soils like that in New York, so
I don't have soil with a very high pH in Michigan too. So the only thing I can comment, you know, it's a take a look at the vines, the way they're growing. If you see a lot of problems in some deficiency, mineral deficiency, is something you need to adjust, and it's not difficult to see mineral deficiency, you know, or just looking at the vines, the color of the leaves, or maybe collect some leaf samples or petiole samples of bloom and variation and send to the lab for analysis.
Yeah, typically at the higher pHs you might see iron deficiency. That would be general yellowing of the leaves, or phosphorus, I believe is the other one. So, so that might entail some differences in management, but maybe some of our Midwesterners with that prairie soil and those limestone soil base can answer this better than we can.
Yeah, I'd say that you know, maybe Mike White has had some experience in talking with people who have really high pH soils. He's at Iowa State. He might be a good source to talk to about something like that. So then also Tim just commented that the titratable acidity for Marquette was really low compared to what we saw here in Michigan. Here in New York, geez. So then some other people said that they've gotten TAs down around 8 to 13 in Quebec, and Greg Cook, which I'm not sure where you are, Greg, said that he also got TAs down to 8 to 10. Oh, Fargo. Okay, thanks, Greg. So it seems like they've got a pretty wide range in TAs depending on location.
Yeah, you know, I have 2 years of data and a CPH that goes between 10 and 6. So the 2 years were completely different, and there is a huge impact of the climate on TA. And I want to just, you know, so any place you go, grapes is different, and we're growing grapes for this experiment in the Southwest. It's a pretty warm site, and it's in the heart of one of the appellations that we have in Michigan. It's very close to the lake, very sandy soil. We get an average of 3,200 growing degree days as an average year. We can get up to 4,000 growing degree days in a very good year, like happened in 2012 and 2007. And just to give you some numbers to think about, 4,000 growing degree days and what they get every year in Napa Valley. So it's a very, very warm site, and the season is pretty long.
That's a very good point. If I can jump in, yes, that's a very good point. Because certainly our stuff up in Watertown, which is on the east side of Lake Ontario, we might be challenged to get 2,400 growing degree days there. And so since the acidity, that sort of reflects heat and respiration in the vine, that makes total sense to me.
Correct. So that's where we're going. So I was going. So with a very high temperature, so acid degradation can be very, very quick because it's related to respiration of the berries. Plus, we harvest the grapes very early, and that's the first week of September. And I want to, the Southwest in general, we harvest Pinot Noir at the end of September, and Cabernet Franc at the end of October. So these grapes are ripening in a very, very warm temperature in the middle of the season, very, very early. So between the temperature and the fact that we put this cluster under the sun, having 7 grams per liter of TA is something I think we can reach consistently every year. The challenge will be to control the sugar accumulation, and because these grapes can get very high level of breaks. So we don't want to reach the 26 to 27 breaks that you saw from my correlation data, and that I think is the time which we need to think about how we can manage the breaks accumulation, maybe with crop load experiments at the same time, working on the management of TA with cluster exposure. And I hope we can do this work next year because we have a couple of ideas on to manage better the ripening profile of these grapes.
Okay, well, we have run a little bit over time, so I think that's it. I'm going to post the link to the post-webinar survey again. Thank you so much for taking the post-webinar surveys. We really do use the information from those, so please go take it. So with that, that's the end of the webinar, and that is the last noontime presentation anyway for the 2014 Spring Webinar Series. So thanks a bunch, Tim and Paolo, for your presentations today. They were great. I think that everybody really learned a lot. And thank you to everyone who participated today and who's participated in the webinar series. It's really a fun thing, and I really do think that it's a great way to gain knowledge and to share knowledge too. So with that, thanks, and see you later.
Thank you, Paolo.